Okay, I want to continue writing this basic language program to divide two polynomials. In particular, I want to take an nth order, nth degree polynomial, p sub n of x, and just divide by a linear polynomial, b1x plus b0. Okay, so we're just dividing by this. Now, I ran into a problem as I was writing my program. And here I have it right here. I have that program right here. It's pretty much, this is the program that I ended up with. And the problem was that I forgot that a third degree polynomial, for example, a polynomial third degree, actually has 4 coefficients. Let's look up here. And that if n is 3, our polynomial looks something like this. It'll be a cubed x cubed plus a2. It's not a cubed, it's a sub 3. A sub 2 x squared, and then a sub 1 x, and then the fourth coefficient is a sub 0. Okay, I forgot about the fourth coefficient in my first attempt at the program. So I would put in, let's say that the polynomial was third degree, and then I would only ask for 3 coefficients. I need to put in 4. So how am I going to deal with that? Let's say, remember I dimensioned the coefficient array to have 10 elements in it, so that means we can handle at most a ninth degree polynomial. I put in the degree of the polynomial, and then I input the coefficients for I equal 1 to n. But it appears that what I need to do is I need to add a statement, let's say 25, where I say n plus 1 equals n plus 1. So this now I'm going to go through inputting n plus 1 coefficients, or np1 coefficients. And this statement right here, 40, needs to change. 40 needs to look like p equals np1 plus 1 minus I. So that should give me allow me to input then all 4 coefficients for a third order polynomial. Now let's see if there's anything else I need to change here. Okay, when I'm printing out the polynomial, I need to print out 4 values. So this needs to go to np1 here. Okay, I'm looking here. 40 p equals n. I think 40 was correct. The value of p that I had there was correct. I want p to equal n plus 1 minus I. I don't want to change that. So I made another mistake there. Let's list and see what I have. Okay, p equals n plus 1 minus I. And I want 30. This is what I wanted to change. 30 for I equals 1 to np1. That's what I wanted to change. Now let me list and see what I have. Okay, so I have np1 is equal to n plus 1. I want to input now, let's say, n plus 1 coefficients. So I goes from 1 to n plus 1. And however, the pth coefficient is still n plus 1 minus I, but I'm going to have a 0th coefficient. So when this is equal to n plus 1, p is equal to 0. So that'll be my a sub 0 coefficient. Print the coefficient is, I think I'm right so far. Now here I want to change 100 for I equals 1 to np1 as I'm printing out or perhaps, let's see, I want to go Yes, I want to go NP1 here. 100. 100 needs to print out 4 coefficients and not 3. Print I equals 1, 2, NP1. Okay, let's see if those changes in the program make it work. Let me list it. Okay, run. The degree of the polynomial is 3. Now it should ask for 4 coefficients. 1, 1, 1. There, it asked for 4 coefficients. Didn't give me an error. I have to input B1 and B2. Let me put 1, comma 1. The polynomial is syntax error in line 100. Line 100. Ah, I said print. I meant that to be a 4. That's what the mistake is. 100, 4, I equals 1, 2, NP1. Now let me type run. The degree of the polynomial is 3, 1, 1, 1, 1, 1, comma 1. Okay, so it's giving me all the coefficients for all the polynomials, giving me what the divisor polynomial is. Now let me just run this again. Let me put in different numbers here to see if it's putting the correct numbers in the right place. The degree of the polynomial is 3. So I'll put 1, 2, 3. Let's put 4. Let's put 5, comma 6. Okay, so 1, 2, 3, 4. The divisor polynomial is 5x plus 6. Okay, looks like this is running correctly. Okay, now after we have figured out how to get the program to, let's put list. So you might want to save this if you have it, because the next thing we have to do is we have to figure out how to actually compute the coefficients of the quotient polynomial and the remainder after we divide things here. So in other words, let's go back to this statement right in here. And let me pull this down. Let's see, here we go, right here. Okay. What I've done is a sample example here to give you some idea what we're going to need to do. So here I have a 4th order polynomial, 4th degree, dividing it by b1x plus b0. Now remember when we talked about dividing polynomials, we could take our polynomial, divide it by this. What that means is that polynomial p sub 4 of x is equal to this times this quotient polynomial q of x, and then we have the remainder polynomial. So what we're actually trying to compute is q of x and r of x. Okay, now see there's quite a bit to discuss here, so I'm going to do that in the next video. So until next time.